In this video, we are going to look at one application of quadratics and look at a summary of the 4 methods that we've learned. You're going to take your notes in your booklet on pages 11 and 12. So the application we're going to look at, because there are many applications of quadratics, the one that we're going to look at is modeling the height of an object in motion. So to model means to represent using an equation. And this is going to be something that you're going to do in your science classes quite often. This is our general form for modeling an object in motion. So I'm talking about hitting a baseball with a bat, talking about throwing a basketball, talking about shooting a rocket out of a cannon. So we're measuring our height with respect to our time. We're writing an equation there. Okay. I should mention this specific equation has to be height measured in feet, time measured in seconds. If you change one of those, the -16 changes. Now, the v naught, that little v with a 0, is our initial velocity. So it's how hard we hit the ball to begin with. And the h naught right there, that's our initial height. It's where the ball is starting from. Obviously, there are other factors that come into play. We're neglecting those factors for now. We're just concentrating on those two, the initial velocity and the initial height. So what I'm going to do on this little cartoony picture, I'm going to draw in an axis so we can have a better understanding of what it is that we're doing. So our x-coordinate, or our x-axis, is actually going to be t. That's our time. That's our independent variable. And our y-axis is going to be h. That's our height. Our initial height is where the ball was thrown from. So that's our h sub 0. There are 2 other important points that we want to look at. Remember, your vertex of your parabola, since this is a quadratic, it's going to be a parabola, your vertex is going to be that highest point. So that's going to give us our maximum value, or in this case, maximum height. And then this point right here, that's when we hit the ground. So that's where h equals 0. All right, let's look at an example. So we have a ball is 3 feet off the ground when it is hit with an initial velocity of 47 feet per second. So this right here is our initial height, and this right here is our initial velocity. If we go back to our generalized form, the -16 t squared plus v naught t plus h naught. I'm going to just replace the v naught with 47 and the h naught with 3. And that's it. Now I should mention the -16, that's coming from the effect of gravity on the ball. That's what's happening there. And that's our equation. So all I did was replace my initial height and my initial velocity. Now, for drawing a sketch, it's going to look pretty much exactly like this cartoon here. I only do the first quadrant because time has to be positive, and the height of the ball is, or the height of the object is going to be positive. So this is our t, and this is our h, with our initial height being 3. So I'm not going to fill in all the other numbers. I'm just going to fill in that initial height. It was hit, so it's going to come up, and then it's going to come down right there. And that's it. That's our quick sketch. Now, we're going to ask 2 questions. What is the maximum height the ball reaches, and how long will it be until the ball hits the ground? Now you can see our equation here is kind of ugly. So what I'm going to do is I'm going to use technology. I'm going to go to Desmos, and I'm going to graph the -16t squared plus 47t plus 3. So I am going to graph y equals -16t squared, I could have put an x in there if I wanted to, plus 47t plus 3. And I'm going to adjust my axis here to go just 1 to 5 and my y. So I'm just playing around with my grid here. Let's just go. I'm going to pause and get it just right. Okay, I played around with it to get it just right. Sometimes that takes a minute. Now you'll notice here my initial velocity, my initial height is 3. Right? So where I'm crossing the y-axis is 3. Now, the first question that was asked, what is the maximum height the ball reaches? For that, I'm going to go to my vertex. So this is when it happens, the 1.469, that's my time. My maximum height is 37.516. So I'm going to just fill that answer in. So I'm using technology so I don't have to do all of that arithmetic. 37.516. It's a height, so we're going to put feet because we're measuring in feet here. Let me make sure I got that right. Yes. Now, the second question that is asked was, how long will it be until the ball hits the ground? So remember, the y-axis is our height. So where does it hit the ground? It hits the ground when your height is 0. So at your x-axis. Notice I also have an x-coordinate over here that's 0, or a y-coordinate over here that's 0, but my time there is negative. So I can't use that one. It doesn't make sense to have a negative time. So it's just going to be at 3. So how long will it take the ball to hit the ground? T equals 3, and again we're measured in seconds. So we'll put seconds. Now, I know this is a little confusing. We will continue to work on these. I just wanted to introduce you to the concept in this video. We are going to go ahead and also look at page 12. We're going to do a quick review of all 4 of our methods and the types of solutions we can get. Okay, so 4 methods that we did: graphing, square root, factoring, and quadratic. Methods for solving quadratic equations. For graphing, you're going to use this when you have the graph or you have technology to graph it. So, for example, that last problem, this was a yucky equation. I used technology to graph it and used technology to answer the questions that were asked. So I'm going to do that whenever they already give me the graph or if I have technology in order to graph it, like Desmos. The square roots are going to happen when b equals 0. This is important. So if you have something like 6x squared minus 3 equals 21. That you can solve using square roots because there's no x term. So your b is 0. Factoring you're going to use when it's easy to factor. That's basically what it comes down to. So you'll get it into standard form. If it's easy to factor, use factoring. And then the quadratic formula always works. So if you are going, which method should I use? Quadratic formula always works. So that's a good one to go to. Remember, one of 3 things can happen to us. We can have 2 real solutions, and I'm actually going to look at the graph over here. I did the work. I solved this one using factoring, but what I want to point out on the graph, I've got 2 x-intercepts, 2 roots. I have 2 answers there. They're both rational. Sometimes they'll be irrational. You'll get that 0.79321, right? You'll get the square root that you can't take the square root of. You can also get what's called a double root, where you get one answer. Really, you get the same answer twice. That's going to happen when your vertex is on your x-axis. And the last thing that happens is you can get that negative under your square root. For right now, we're just saying no real solution. Later on, you'll learn about complex or imaginary solutions. That's going to happen when your parabola does not cross your x-axis. So we are basically done with solving our quadratic equations. We're going to do some review, then we're going to be ready for our test.